Hello, good day viewers. We're asked to evaluate the complex number 1 plus I raised to the power of 4n plus 5 divided by 1 minus I raised to the power of 4n plus 3, for which n is a natural number. All right, let's get started. If you observe, the only difference between their exponents is 2. So why won't us reduce this one? We can do it applying one of the laws of indices. So to the top, we can now write it as 1 plus I squared multiplied by 1 plus I to the power of 4n plus 3. Because if you take one base and add the powers together, you're going to get 4n plus 5. Then we divide this by 1 minus I to the power of 4n plus 3. So, by applying one of the laws of indices, we can assign these two terms a single exponent because they have the same exponent, right? So this one remains the same, but let me just simplify that. 1 plus I to the power of 2 can be simplified as first term squared, which is 1, plus second term squared, which is going to give us I squared, then plus 2 times the first term times the second term. 2 times 1 times I is 2I. Then we have the other one multiplied by 1 plus I divided by 1 minus I to the power of 4n plus 3. Now I want us to simplify what is this first before we raise it to the power of 4n plus 3. But from this side, you know that I squared is -1. So we have -1 plus 1 is 0. So we only have 2i. So we have 2i multiplied by 1 plus I divided by 1 minus I, which we can multiply the top and the bottom by the conjugate of the denominator just to make it real, right? So we have 1 plus I divided by 1 plus I to the power of 4n plus 3. This is equal to 2i multiplied by, to the top you can see we have 1 plus I multiplied by 1 plus I, which is the same thing as 1 plus I all squared. And we have just simplified that, remember, as this one, right? Which give us what? 2i. So to the top, we have 2i. To the bottom, we have difference of 2 squares. But remember that I squared is equal to -1. If you take the first term, you square that, which is 1 squared. You subtract, you take the second term, you square that, which is I squared. It will give us -1. Another negative here, so we have +1. We are moving. Okay, remember our exponent is 4n plus 3. So this is equal to 2i multiplied by 2i divided by 2 to the power of 4n plus 3. 2 will cancel 2, leaving only I. So we have 2i multiplied by I to the power of 4n plus 3. And from here you can see we have common bases, I, so we can take one base and add their exponents. You know, this I is to the power of 1, right? So from one of the laws of indices, 2 remain as a factor. We have I to the power of what? 4n plus 4, because 1 plus 3 will give us 4. And this can be splitted as 2 multiplied by I to the power of 4n, then multiplied by I to the power of 4. From here, we are almost done because we know that I to the power of 4 is 1 and all multiples of 4. I to the power of 4 is equal to 1. I to the power of 4 plus 4, 8, equal to 1 again. I to the power of 16 equal all multiples of 4. And you can see whatever number you multiply 4 by, it is going to be a multiple of 4. So this is 1, this is 1. 1 times 1 is 1, times 2 is also 2. So the whole of this is equal to 2, which implies that if you evaluate the whole of this given expression, you're going to obtain 2, provided that n is a natural number. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.